All right, welcome back. Here we're in the last section of Chapter 8, Section 8.3, which we're going to estimate the difference in proportions. So we're going to kind of go in that route, kind of a shorter chapter type thing that we have here. By the end, we should be able to determine whether the conditions are met for constructing a confidence interval, about a difference between two proportions, and then we should be able to construct and interpret a confidence interval, making sure we can use that four-step process that we used before. So remember, conditions that has to be random, has to be for randomized experiment. 10%, their sample sizes have to be less than 10% of the populations of the two populations, and then of course our large counts condition, the successes and failures in each sample. If we take the sample size times the success and the sample size times the failure, they all have to be greater than or equal to 10 in those cases. So let's get right to a problem and let's verify it. So a Harris Interactive Survey asked independent random samples of adults from the US and Germany about importance of brand names when buying clothes. Of the 2,309 U.S. adults surveyed, 26% said brand names were important, compared to 22% of the 1,058 German adults surveyed. Now, we're going to use the proportion view be the U.S. and proportions, so use the subscript G for German. And we're going to check the conditions to see if it's met, if the interval, it should be a minus there, P sub U minus P sub G are met. Let's see if we got it here. All right, it is random. We did random samples, so we're good to go there. 10%, yeah, those are all way less than 10% of the U.S. adults and German adults, so we're okay there. Now, if we take the sample size times each of the proportions of success and failure, yeah, we're way above 10, and we're all good to go there. So we're good. That's a good way to verify those intervals. Okay. Now remember, the way we're going to do is we're going to take our statistic plus the critical value times the standard deviation of the statistic. Thinking of that, what we're going to do is we're going to subtract the two proportions plus or minus our z-score, and then we're going to multiply that by the standard deviation of our statistic. Okay, and find that standard deviation. Remember, once again, when we're subtracting those two proportions, we've got to do those both parts here. We got to take the probability of success on the first one times failure divided by sample size, do the same thing for our second population, add them together, take the square root is what we're going to do there. All right, so again, so we're going to use the proportions which are known. We're going to end up using our estimates there with p hat, so we're going to adjust the formula just a little bit in that regard. Okay, so we're going to call that the standard error. That's what we call that. Okay, now when conditions are met, C % confidence interval, okay, and we'll get that with our Z table, whether it's 90, 95, or 99 typically. We're going to find it by doing this. We're going to find the difference between the proportions plus or minus our critical value from our charts, our z-score, and then times our standard deviation is what we're going to use. So write that formula down, have it handy. Should be on our handy dandy notes on our z tables right there for us to use as well. So make sure we know how to use those. All right, so far we focused on doing inference using what we call random sampling. In this case, we're going to do a randomized comparative experiment is what we're going to do. All right, so we're going to take a look at some back pain is what we're doing. And oftentimes they're given a non-steroidal anti-inflammatory drugs like naproxen to help ease their pain. Now, researchers wondered if taking Valium along with the naproxen would affect pain relief. To find out, they recruited 112 patients with severe lower back pain and randomly assigned them to one of two treatments. They either got the naproxen and Valium or naproxen and placebo. And after a week, 39 of the 57 subjects who took naproxen and Valium reported reduced lower back pain, whereas the 43 out of the 55 that had the naproxen and the placebo group. So what we want to do is construct and interpret a 99% confidence interval for the difference in proportions of patients like these who would report reduced lower back pain after taking naproxen and Valium versus taking naproxen and the placebo. And then we're going to make a conclusion on whether or not we think adding the Valium is an effective way to treat pain relief, and we're going to try to justify that. So a good problem, really applicable here as you take a look at it. All right, so here we go. So let's take a look. Let's see how we would construct and interpret our 99% confidence interval. Let's use our four-step process here. So let's state it. So we want to find a 99% confidence interval for the difference in the proportions of those who had the different treatments. Naproxen and Valium was P1, naproxen and placebo was P2. P sub 2. All right, so we've got those. Now what we're going to do is again keep a good exam tip here as they talk about this, make sure that you're defining the parameters in experiment. Make sure that you're making sure that you're using those proper labels as we're going through. Okay, now our plan is to use the 2 sample z interval for the difference of the proportions, the true proportions. Now it is random. Okay, we randomly assign them. We don't really have to check the 10% because we did not sample patients without replacement from a larger population, so we're okay there. And then our large counts, you know, all those things, they're all bigger than 10, so we're good to go on all that. Okay, so let's do the do part. Let's find the proportion of 1. We had 39 out of 57, so our proportion is 0.68. In our sample of those in the placebo group had 43 out of 55, so 0.782. So to do this, we take the difference of our populations, our proportions here. Now the 99%, if we look at our z-table, again, that's going to be at positive and negative 0.2576. If you want to use the calculator, probably 258 is 2.58 is probably what you get out of the chart. All right, so then we go through our standard deviation. So take the success times failure divided by sample size, then do the population, success, failure, again, sample size, put that all together. So we get our 99% confidence interval with the margin of error here. We have a 21% margin of error. That's pretty high. But again, we're going to see our interval is going to go from negative 0.312 up to 0.116. That's our interval that we have. Okay, so now what does that mean? Well, let's interpret that. That's obviously what we're going to do. We're going to conclude that 99% confident that the interval captures the true difference of the proportions of patients like those who would report reduced pain after taking naproxen Valium versus taking naproxen and a placebo for a week. So we're 99% confident that that interval contains the true proportion of that. All right, now knowing that, okay, what can we say about the effectiveness of that? Well, as we take a look, well, yeah, 0, which means that there's no difference whatsoever. Since that's part of the interval, I'm going to say, yeah, I don't think that it's really any more effective, and it's probably not worth prescribing and doing. Well, let's look for other treatments. So again, it's not a good one, at least for patients like this, I would have to say. All right, so again, just never suggest that you believe the difference between the true proportions is 0 just because it's in the interval. Just say that it's in the interval, so therefore we're going to say that it's not. But don't think that it is exactly 0. Okay, but it's sort of worth a mention. Now the TI-84 that we use can be used to construct this as well, and I encourage you to use the tech video here. In this situation, we're not going to run through it. You'll see screenshots like this that in the tech corner on Moodle. We have a fantastic, on our online program, we have a fantastic instruction step-by-step. Always use those Tech Corner videos. They're fantastic. Walk you through it, and then when you get a chance to do the computations here, wow, they can really save you a lot of time. And they encourage you to use that because there's a lot of places to make some mistakes. So again, it's the 2-prop Z and feature that's used. The 2 sample Z interval is what it's called, and again, name that, and again in the plan step, and give the interval in the do step. So just go ahead and make sure whenever you use a calculator, write down what you're putting in, as always, so that we can see what you're thinking, and the people that are grading can do it as well. All right, so again, we should be able to decide the conditions, the randomness, the 10% law of large counts numbers as well. We should be able to construct that confidence interval using that. We have the formula, we also have the calculator. Look at those videos and then get a chance to practice those on page 574. Some good exercises, 61, 65, 67, 71, and then those multiple choice, 73 through 75 were fantastic. We'll do those. We'll work on getting a FRAPI and the multiple choice formative assessment, get ourselves ready to go, and that'll wrap up Chapter 8. Until next time, I'm Mr. Broden.